Hi everyone. Today we're going to go over 3.4 day 2 notes. It's very similar to 3.1 day 1 that we just covered. Alright. So you'll notice the topic here says solving natural log. That's what LN stands for. Natural log and E. Okay. It's the same exact thing that we did last class, except this time I'm talking about natural log as well as E, but the same steps are going to occur. All right. The biggest thing we need to remember as we continue through these notes is to know that natural log is the same exact thing as log with a base E. They are interchangeable. Okay, so if you ever see natural log, you know that it's really log with a base of E, or vice versa. If you ever see log base E, you know that you are now talking about natural log, right? And if you look really quick on your calculator, whether it's the app, it's on a physical calculator or what have you, go ahead and find your natural log button on the calculator. Okay, that should be on the left side and the third one from the bottom. And if you look directly above ln on the main plastic piece on the calculator, you will also see the letter E raised to the x power. So if we ever need to use that on the calculator, you know where your ln button is, and then the E portion you're going to access by hitting the second button and then back to your ln so that you can get that piece in blue. All right, so we will use that today. So we're going to just have a few examples and we'll talk about each one. So for question 1, it says e to the x plus 4 equals 2. All right. Now the directions are asking us to solve. We are solving for x. So right now I can't do anything with this problem because x is in my exponent. I can't type it into the calculator because I would only have the x button to use, and the calculator doesn't know what x is, so I can't do that. But what I can do is I can convert this problem from exponential form into logarithmic form. And when I convert, you will see why that was helpful to us. All right, so again, your base here was E. It was on the left side, so you're going to keep it on the left side. And your base is now going to move into the basement. Once you move it to the basement, you're going to switch the other two terms. So 2 is going to come over on the left side, and then x plus 4 will go over on the right. Now remember, log base E is the exact same thing as ln, so I can convert that piece. Log base E changes to ln. I continue with 2 equals x plus 4. Okay, and then as you keep going, notice that ln2 we can actually type into our calculator. So right away we get to use the calculator. So on your calculator, go ahead and type in ln2 and hit enter. And you should get the answer 0.69314711806. And then you still have it equal to x plus 4. All right. Now, if you're someone who doesn't want to write down all those decimals, that is okay. However, when you're doing your work in the calculator, keep the original values. Never round until the very, very end. Okay, if you round in the middle of your work, you're going to get the wrong answer and things won't work out that way. Okay, so I don't mind if you want to shorten the decimal in your handwritten work. Just make sure that you're using the real answer on the calculator. All right. And so if I go and I keep solving for x here, I'm going to want to subtract 4 to both sides. In the calculator, you can just go immediately into hitting the subtraction sign, minus 4. It'll take your answer from the previous step, so it will take that entire decimal and subtract 4 from it. And you will have negative 3.3, and this time you can round, and we will round to the nearest hundredth, and you'll have negative 3.31 equaling your x, all right? Now, if you remember from last class, we wanted to take this answer and we wanted to check it, okay? And the only reason we did that is because we had everything last class. Things were in terms of log, Okay, more importantly, oops, let's use this here. More importantly, when I have logs, when you start with logs, so if your original function has logs in it, then you need to check. And we'll see this more as we go through these problems. Okay, and by check, I mean we got to take that value and we got to plug it back in. All right, we don't have to check this negative 3.31 in this function because negative 3.31 is going to end up going in the exponent, and we're allowed to have zeros for our exponents. We're allowed to have negatives for the exponents. So that rule doesn't apply. It only applies when I start with logs. So if I had a function that said something like log base 2 of x plus 3 at the beginning of my problem, that's when I would have to check my answer, plug it into x, and check for zeros or check for a negative. If that ever comes out 0 or it ever comes out negative, then you automatically have no solution. Okay, but again, we did not have to do that here because it gave it to us as an exponential at the very beginning. So don't forget that step to check. For question 2, okay, they gave us natural log 6 plus natural log x minus 1 equals 0. Okay, so looking at this, right away they gave us natural log. So that tells me that I am going to have to check at the end, because this time they gave me a question with log in it already. I know it's natural log, but it's still considered a log function. Okay. Now I know I have to check at the end, but I can't get there unless I solve. So if you remember your rules with logs, your logarithmic rules from section 3.2 and 3.3, all right, give those a look if you need that refresher. Whenever I am adding logs together, okay, we can't have two logs in the same question on the same side. Okay, we always only want a single log. So by condensing this into a single log, I need to look at that plus sign. That plus sign is going to tell me how I can move forward. All right, and this is where that 3.233 notes come in handy. Whenever I add my logs together, it's going to tell me that I need to multiply the main terms. All right, so I'm going to condense them from two natural logs into just a single natural log, and then the main terms come together by getting multiplied. So I went from 2 natural logs down to 1 natural log, and then 6 and x minus 1 are going to get multiplied. And now let's keep going. I'm going to do 2 steps at once here. So I am going to rewrite natural log as log base e. Okay, same thing, it's interchangeable. I'm allowed to write it with a base just so I can see it a little bit better. And then at the same time, I'm also going to distribute the 6. So I have 6x minus 6, and it still equals 0. Okay, you have a single log now. We can take that single log, and now we can convert. So if you get stuck solving these, my biggest advice I would tell you is you're going to end up having to convert. Every single question when we are solving, you have to convert at some point in time. So if you get stuck and you don't know where to go, maybe that's your time to convert. And the only times you can convert is when you have a single log on one side only, and then you can obviously make your base out of it and so forth. Okay, so when your rules for converting actually work. If you have 2 logs, you cannot convert at that moment. So I have a base e from the basement that's now going to go into my base on my exponential form. And then, excuse me, and then 0 and 6x minus 6 are going to switch sides. 0 now goes to the left, and 6x minus 6 will go to the right. All right, now we have things in terms of e on the left-hand side. That's fine and dandy. I can type that into the calculator if I would really like to. Or I can use my knowledge of exponentials, and I know that anything raised to the 0 power is always going to be 1. So e to the 0 power changes to just 1, and I'm going to keep solving. Add 6 to both sides. I have 7 equals 6x. Bring my work here. And I'm going to need to divide both sides by 6. And I have x equals 7 divided by 6. Okay. Before I box this answer, though, remember what I have to do. I need to check. So I need to take that 7 over 6 and go back in to the function and replace x with 7 divided by 6 and make sure that it doesn't come out as 0 and make sure it doesn't come out negative. So if you do that, you will end up with 1 over 6 or the decimal, whatever that is. But regardless, it's still positive, which means I am allowed to circle that as my answer. It's going to work either way. All right. Looking at question 3 now. It's the same kind of idea, all right? This time I have 4 different natural logs, but more importantly, I'm going to focus on just one side at a time, okay? So if I look at just the left-hand side, I don't like seeing 2 natural logs together, so I'm going to see if I can get it down to 1, see if I can condense them. And the way I do that again is by checking the symbol in between. This time I have a minus sign instead of a plus sign, so I'm going to use the quotient rule, which tells me I'm going to need to divide. All right, so the way I do that is I have 2 natural logs. They're going to break down into 1, and then your first term, that x minus 8, is going to go in the numerator, and then x plus 7 will go in the denominator. First term, numerator, second term, denominator. Okay, so now you've condensed it. You have 1 term, that's great. Now let's look at the right side and do the same thing. I have 2 natural logs. I see what's separating those natural logs. It is a minus sign, so I need to use the quotient rule again, which is going to make me divide. So I bring them together into a single natural log, and then x minus 10 goes up top, x plus 8 goes down below. Now here, if you remember, natural log is the same as saying log base e. Oops. So I can change these to say log base e. And if you know this information, you don't necessarily need to change it every time. I'm just wanting to show you what's happening here. Okay? If you remember from the last set of notes, whenever you have the same base, the exponents get to equal each other. Okay? The way I like to word it is whenever you have the same base, you get to drop the base and set the exponents equal to each other. Okay? Same thing applies here when we're talking about our logs. If you look at both sides, they're both in terms of log, and they both have the same base of e. So I get to drop the base of e, but since we're talking about logs here, I also get to drop the logs. Okay, just a rule, but it applies to both exponentials and logarithmic functions. So it's kind of nice to remember just in case you get stuck here. Okay, so now I have 2 fractions. I can still keep them equal to each other, but with 2 fractions on either side of an equal sign, I can cross multiply. So let's go ahead and do that. I'm going to write down every single term as I cross multiply. If you can see what cancels and combines, that's fine. I'm just bringing it all together here. Okay, x squared plus 8x minus 8x minus 64 equals x squared minus 10x plus 7x minus 70. So I'm just going to clean up shop here. simplify some things really quick. Their 8x's are going to cancel. And so you're left with x squared minus 64. And then on the right side, you get x squared minus 3x minus 70. And just like last time, as soon as you see a quadratic, we know that we need to get one side equal to 0. So that means I'm going to move everything on the left-hand side just because there's only 2 terms as opposed to 3 terms. So that means I want to subtract x squared to both sides, matching up your like terms. And I'm also going to add 64. So that on the left side I can now get a 0. I'm going to move up here for us. All right. So when I subtract x squared and add 64, I have 0 equals, my x squareds end up canceling, which is nice, and I have negative 3x minus 6. Again, we're solving for x, so our normal rules for algebra apply again. This time I don't have an x squared any longer, so I'm allowed to move that 6 back over. Get in that habit of whenever you see a quadratic, you want to get it to 0. Okay, I know it canceled. That's okay. But get in that habit of practicing getting everything equal to 0. And you have 6 equals negative 3x. Divide everything by negative 3. And you have negative 2 equals x. Before you box your answer, double check. Do you need to check this value? Was your original question in terms of logs? Yes, it was. So we need to go back in, and everywhere I see x, I need to check and make sure that I'm not getting a 0 and I'm not getting a negative. Either one. If I get one or the other, I automatically cannot use that as an answer. So if I plug in negative 2 for all my x's, I get negative 10, 5, negative 12, and 6. Because these automatically gave me negatives right here, because of that negative 10 and because of that negative 12, I immediately cannot use that answer that I had because I ended up with a negative. Doesn't matter if it showed up one time or if it showed up multiple times. All right. Because I just crossed out my one and only answer that I had, how many answers am I going to have left? And the answer to that is no more answers. So your final submission will say no solution because that negative 2 won't work. So you have no answer that will work. Therefore, you have no solution. All right, almost there. Question 4, you can go ahead and pause and go ahead and move ahead on this one. All right, as a hint to get started, you first want to get rid of that 3. All right, we always like, before we convert and do all that every single time, we always want a single natural log all by itself with nothing in front of it or attached at the end. Okay, so if you look closely, you have this 3 here that we need to get rid of, and we have that 7. Okay, so those are the 2 things you're going to have to get rid of in order to continue. So if you want to move ahead, go ahead and pause and try it on your own. And here we go. I'm going to subtract a 3 first. And you're left with 7 natural log x equals 9. And then we want to also get rid of that 7. So we're going to divide everything by 7. And we're left with natural log x equals 9 divided by 7. I haven't converted yet, but now I have a perfect natural log there. That's really nice for me. But I know that natural log is the same thing as log with a base e. So I'm going to change that really quick so it will help me when I go to convert. All right. Same question, same work I have. I just changed it to log with a base e now. So now I'm going to take that base e, make it my base on my exponential conversion, 9 over 7 changes sides, and x goes to the other side. All right? Not the prettiest of things, but the beauty of this is that I have an E button on the calculator, so I can type that in to my calculator. So second natural log, that gives you your E on the screen, and then you can type in 9 divided by 7. And when you do that, you will get the answer, x equals 3.617250785. Okay, that's a long answer. Remember, when you get to your final answer, you're allowed to round, and we're going to round to the nearest hundredth. So we're going to choose 3.62. And just like every single time, so we don't forget it, especially the day of our test, take this answer and always check it. Don't forget that step, okay? You were given a natural log at the very beginning, so we need to make sure that the answer we get at the end does not come out as 0, does not come out as a negative. So if I plugged in 3.62 here, the beauty of this one is that x is all by itself already on the inside of those parentheses, so nothing's going to change it on the inside. So if I know I have a positive 3.62 as an answer and I plug that back in, it's going to remain a positive 3.62. So it will still count as an answer. All right. Question 5 is going to be the hardest question, but we can get through it. All right. You do have a question like this on your test, and you have a question like this on your study guide tonight as well. So practice and see how you feel, but you will have these notes to help you, especially on your study guide tonight. Okay, so to get started, we have 5 raised to the x minus 2 equals 4 raised to the 2x plus 3. Okay, remember that rule where whenever you have the same base, we can drop the base and set the exponents equal to each other. Okay, take a look at your bases right now. You have a 5 and you have a 4. Right now they are not the same base. Okay, I can't change them to both be 20s. I know they have a 20 in common, but when I change bases and I want to get the same base, I can only go down. I can never go up. So my only options for 5 is 5. My only option for a 4, however, can be a 2 squared. I can replace that 4 with a 2 squared. But that doesn't do me any good because I can't replace 5 with a base of 2 at all. I can't figure out what exponent's going to get me back up to that 5. So because of that, I have to take this a different way. I have to do this problem a different way. Okay, it is a lengthy way, but we can get through it step by step. All right. Now remember, this whole section was talking about natural logs and E. So to get started, I'm going to take this entire function and I'm going to multiply it by natural log. Okay. The only reason I'm allowed to do this is because whatever I do to one side, I have to also do to the other. So as long as I do it to both sides, I am allowed to multiply it by natural log. And you will see what's going to happen when I do that. So natural log is going to go out in the front. And we have 5 raised to the x minus 2. And the same thing with the 4. Natural log goes out front. 4 is the main term with 2x plus 3 up in the exponent. All right. Now, if you remember your logarithmic rules, again, coming from 3.2 and 3.3, we have these exponents. Normally, we don't have exponents with log functions, so there's a rule for this. It's called the power rule. All right. What the power rule tells us is that we can take these exponents whenever we have it in terms of log, or in our case, natural log. We can take the exponents and move them to the front. Same thing with the second one. Move it to the front. That's the power rule. All right. So when I do that, include your parentheses still. And it just gets moved to the front here. We're just rearranging this and trying to solve for x at the same time. All right. So now with the parentheses out front, I can actually take care of distribution. I can distribute my parentheses into my natural logs. So when I do that, we're going to keep those terms in the front. So when I multiply x times natural log 5, it's going to come out as x ln 5. And then I also have to multiply the minus 2, and that will come out as negative 2 ln 5. Same thing on the right-hand side. 2x ln 4 plus 3 ln 4. Okay. Take a step back here and look at our new line, our new function. Okay. Remember, we are asked to solve for x. So if I take a step back and I look and try to find my x, I have one here and I have one here. Okay. So they're kind of all over the place. So if I want to solve for x, let's get all of my x terms to one side and every other term over to the other side. Okay? And what I mean by that is if I want all my x terms on the left-hand side, for example, I want to subtract this 2x ln 4 here, and whatever I do to one side, I need to do to the other. Okay? However, I cannot subtract it here. I cannot combine these terms. And the reason I can't do that is because you have ln 5 versus an ln 4. Okay, they are not like terms. Remember how they weren't the same bases? That is why, because they are not like terms. That still applies here. So when I subtract that 2x ln 4, I am going to subtract it right in here, right at the end. Okay. And at the same time, let's move this minus 2 ln 5 by adding it to both sides. Again, it does not count as a like term with that natural log of 4, so I need to add it at the end there. So now I'm going to rewrite my line. I have x ln 5 minus 2x ln 4 equals 3 ln 4 plus 2 ln 5. Okay, that's 3 ln, not 31. Don't get confused. Okay, this doesn't look pretty, I understand, but we're going to get to use the calculator. That's the beauty of this entire problem. We just have to get it to that point first. So again, we're solving for x. We'll take a look at these two functions now on the left-hand side, these two terms. They both have an x in common. Well, if you remember our algebra rules, we can factor out the greatest common factor, and in this case, our greatest common factor is x, because they both have it in common. And I'm left with natural log of 5 minus 2 natural log 4. And everything else on the right-hand side will stay. All right. Last but not least, you have your x right here on the left. So I need to get rid of natural log 5 minus 2 natural log 4. So right now, multiplication is happening between x and that set of parentheses. So the opposite version of multiplication is going to have to be division. So we're going to divide everything by natural log 5 minus 2 natural log 4. And whatever you do to one side, you have to do to the other. Beautiful. Move on up here. These will cancel when I divide, and you're left with just an x. 3 natural log 4 plus 2 natural log 5 all over natural log 5 minus 2 natural log 4. Okay, again, not the prettiest thing, but guess what? This entire thing can get plugged into the calculator. So when you get to this step, you're going to go to the calculator. All right, now depending on what calculator you're using, you want to do one of two things. So if you have the older calculator, you're going to want to include an extra set of parentheses when you type it into the calculator, all right? Just so that you can make sure you type it in correctly. So you're telling your calculator exactly what's in the numerator and exactly what's in the denominator by adding those extra sets of parentheses, okay? If you're using the app or if you're using the newer calculator, go ahead and find the math button, okay? You're going to scroll to the right, and if you read the top of the screen, it will say frac. And on that section, you will choose number 1, where it says n divided by d, and then enter. When you do that, your calculator will give you 2 boxes separated by division. You can type in the exact fraction that we were working with so that you don't have to mess with the parentheses and getting something messed up there. Okay, so in your calculator, type in your numerator, type in your denominator, and you will get a decimal out. Get that practice in. And your final answer will be x equals, again, round to the nearest hundredth, negative 6.34. Again, before you circle your answer, go back and see if you need to check. Okay, remember, when we check, we're only checking the original question. I know I started with this ln over here, but that wasn't the original. The original was all of this in just exponential form. So it doesn't matter if it's going to be negative. It doesn't matter if it's going to be 0. So no matter what, I know that x equals negative 6.34 is going to be my solution. So I can circle it and be on my way. All right. You have 2 assignments that just opened. One is in relation to this set of notes, the 3.4 day 2. That is 6 questions. And then your study guide is 17 questions. All right. More importantly, it's a practice study guide meant for you to practice. The day of your test, you will only have 10 questions, so don't worry about that. If you take a look at the last question on the study guide, question 17, it will look very familiar because it was taken directly from this set of notes. All right. I want you to practice this version with natural log. It is lengthy, so I want to make sure that we know how to do it. But I gave you the same question on the study guide on purpose so that you know the work. We just went through all the work. So if you practice it on your own and you get stuck somewhere, you already have the work here to help you get a refresher. All right. And last but not least, on Teams, I do have the study guide posted. The answers, that is, it's in the Files tab for Unit 3, and then you will see the answers. It doesn't have any of the work, but if you want to check any of the answers for the study guide, they are there. And if you have any questions or what have you, please let me know. I could potentially have wrong answers. You never know. So